Hello and welcome to this video. In today's video, we're going to learn how to create a one-dimensional array in Numpy using Numpy library. So first of all, we are importing the Numpy library, and in order to create a one-dimensional array using the Numpy in Python, we need to have the numpy.array. Okay, so this is the code we need to create array using NumPy. And here we see that I am creating an array, and these are the elements of the array: 1, 2, 3, 4, 5. So there are 5 elements in this array, and the name of the array is array1. After creating and initializing this one-dimensional array, we are simply printing this array. So we use the print function to print this array, array1. Okay, and when we run the code, we see that actually this array is being printed in the output. So here we are creating an array called array1, and to create it we use the numpy library, so np.array, and these are the elements of the array that we are having here. Okay, it's like a simple list. In order to print the elements that are inside my array1, I use the print function, and inside parentheses, I write down the name of my array. This is why we see 1 to 5 here in the output, representing the numbers of my array. Also, in order to understand the type of the array, because there are different types of arrays that we can have, in order to understand the type of the array, we simply write down, first of all, the type. Inside parentheses, I write down the name of my array. So the name of my array is array1, is inside the parentheses of the type function in order to understand its type. And in order to print its type, I use the print function here. Okay, so I use the print function, then to print the type of the array1. And we see that the type is from the numpy array. Basically, this is how we can have a numpy array. So I can have array2 equals np.array, and then we can have here, for example, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So this is another array that I am creating here. It is called array2. It's a numpy array, and the elements are from 2 to 10. And now if I want to print it, I simply use the print function and write down the name of my array, which is array2. So when I run the code now, I see that these elements are being shown in the output from 2 to 10. Also, we can have the type of this array2 to be printed in the output. So when I run, we see that it's a numpy array. Basically, this is how we can create and display a one-dimensional array in Python using NumPy. Thank you. Welcome back. In today's video, we're going to talk about the type of arrays that we can create. So here is another example. We are importing the NumPy as np, and we would like to create an array. So np.array, and then we are having 3 elements in our array: 1, 2, and 3.5. Then separated by a comma, we can have the keyword dtype equals float, telling the compiler we would like to have a float array here using the numpy, and we name it array4. And then we are printing array4, and we see that here we are having the exact same numbers: 1, 2, and 3.5. And if we want to print the dtype, let's say the type of the array, we simply use the print function. We write down the name of our array dot the keyword dtype, and it is going to give us the float in the output, meaning that it's a float type of, this is an array of the float type, let's say. But if I put it to be integer here, int, if I put it here, you see that we are having 1, 2, and 3.5. However, in the output, we are seeing 1, 2, and 3. So everything is seen as an integer. And also, the type that is being printed in the output is an integer. So here we learned how we can have an array that we can decide its type as well. So here I would like to have another array. My array equals np dot array, and we open the parentheses. Inside square brackets, I'm going to have the numbers. Then I put a comma. Then I would say d type equals float, for example. And finally, I'm going to print my array. We see it here. So this is my array. 1, 2, 3, 4, 5. And if I have, for example, 2.3 here, 4.6, 5.9, for example. So these are the numbers that I have in my array, and I would like it to be of type float, and we see it in the output here. 1, 2.3, 3, 4.6, 5.9. And when I print the type, we see that it's of float type. But if I change it to be integer, int, when I run, we see that every number that we had there is rounded down. So 1, 2, 3, 4, 5, exactly that what we have here, but they are rounded down to the closest integer. So 1, 2, 3, 4, 5, and it's of integer type. So in this video, we learned how we can have the type of the array being declared while we are creating our array using Numpy. Thank you for watching. Welcome back. In today's video, we're going to learn how we can convert a Python list to a NumPy array, and also we're going to learn how to convert a tuple to a NumPy array. So first of all, we're going to import NumPy as np, and this is a list that we are creating here. So this is a Python list. So the Python list is this one. So we are having 1, 2, 3, 4, 5. This is my list in Python. And in order to convert it to a NumPy array, I'm going to write down np.array. This is the keyword that we've been using. Inside parentheses, I'm going to write down the name of my Python list. And it is assigned to a variable called array. And we are printing this array. So when I print this array, we see the exact same numbers in the output as we had here. But the difference is that this one is the NumPy array, but this one is the Python list. So if I print also the py list, and here I write this message as well. So this is the NumPy array. This is the Python list. So when I run this code, we see that this is the NumPy array, and this is the Python list that we are having here. So the first one is the NumPy array that we converted it. This is the array being printed. The second one is the original Python list that we had it here. So in order to convert a list to a NumPy array, we simply write down np.array, and inside parentheses, we are going to write down the name of the list we want to be converted. For example, now if I have another list, I simply write down np.array, and inside to parentheses, I should write down the name of my Python list. Okay. And this should be assigned to a new variable. A new variable. So this was how we could convert a Python list to a NumPy array. Now we would like to convert a tuple to a NumPy array. So here is my tuple. Here is my tuple. We are having it inside parentheses. You see it here. And these are the elements 10, 20, 30, and 40. And the name of the tuple is py underscore tuple, meaning that Python tuple. Now, again, with the same methodology, we can change and convert this tuple to a numpy array. So in order to do that, I write down np.array, and inside parentheses, I write down py underscore tuple. When I write down py underscore tuple and use the np array, compiler is going to convert this tuple to a numpy array and assign it to array2, and we are simply printing array2 here in the output. So we see that this is the numpy array. Let me add this message here. This is the numpy array. Also, if I want to print the tuple, we could have, this is the Python tuple, and here we are going to have py tuple. So when I run, we see that this is the numpy array that is being here printed from this tuple. So this is the tuple. This is the Python tuple 10, 20, 30, and 40. And this is the NumPy array 10, 20, 30, and 40. So in this video, we learned how we can convert a Python list and a Python tuple to NumPy arrays. Thank you for watching. Welcome back. In today's video, we are going to learn how to create arrays using different NumPy functions. First of all, we would like to create an array filled with zeros. In order to do that, we use the np.zeros, and within parentheses, we're going to write down 3 and 3, meaning that we're going to have a 3 row with 3 columns array, and all of the elements are 0. So when I run the code, we see that we are having an array of 3 rows and 3 columns, and we see that all of the elements are 0. 3 rows, 3 columns. Okay. How do we know that we are having 3 rows and 3 columns here? Because we choose 3 rows and 3 columns here. If I want, I can have, for example, 3 by 5. When I run, we see that I have 3 rows and I have 5 columns. Okay. In order to have an array filled with zeros, we simply use the zeros function, and in parentheses, we choose the rows and columns, and the name of my array is the zero array. And when I'm having the zero array here, we see that when I want to print, I write down this message, array of zeros, and here we are having the name of my array. So when I run the code, we see that we are having array of zeros in the output. So let me comment this part. Then we can have an array filled with ones. You see, here I'm having an array that is having 3 rows and 3 columns, and all of the elements are 1. So again, here is the number of rows, here is the number of columns. So we can have 3 by 5, for example. When I run, you see we are having 3 rows and 5 columns now. But one important thing is that we are using the ones function. So the ones function is going to help us to create an array with 3 rows and 5 columns that all the elements are number 1. And we assign it to this name. So the name of my array filled with number ones that has 3 rows and 5 columns is ones array. Then we are going to print this message, array of ones, and we write down the name of the array, so we see that it's in the output here. Then the next thing that we can have is we can have an array of 3 by 3 filled with number 7. So when I run, we see that we are having an array that is 3 by 3, and this array is filled with number 7. So if I want, I can have 3 by 5, for example, and all of them are filled by 7. We can have all of them filled by 5, for example, or all of them are filled by 14, for example. So if we want to create an array filled with a specific value, we can simply write down the name of that value, and these are the dimensions of our array. Simply, we need to use the full function. And if I comment this part and go to the next one, we see that we can create an identity matrix that has here all zeros except for the diagonal. Okay, for the diagonal we're having number 1, so this is the identity matrix. The other elements are 0. In order to create that, we write down the function called I, and we put number 3 to have for example a 3 by 3 matrix. If I want a 5 by 5 matrix, we simply write down number 5. So we are going to have the 5 rows and 5 columns, and the diagonal is filled with number 1. So we are going to call it identity matrix, and we are printing it here in the output. Finally, we learn about how to create a matrix that has a diagonal with specific elements. So here I use the dig function, and we decide about the specific values that we want to be shown in the diagonal. So 1, 2, 3 are the numbers that I am expecting to see in the diagonal. So if I add one number here, for example, number 4, we're going to have a 4 by 4 matrix. So if I have 5 numbers here, I'm going to have a 5 by 5 matrix here. Okay, so in this video, we learned how to create an array filled with number zeros. All of the elements are zeros. We learned how to create an array that all the elements are number 1. We learned how to fill an array that all the elements are a specific number, for example, number 7, or any other number that we choose. We learned how to create an identity matrix, and also we learned about the specific elements that we can have for our diagonal matrix here. So we see that we are having a 5 by 5 matrix, and the diagonal is having the specified elements that we chose here. Thank you for watching. Welcome back. In today's video, we're going to learn about different operations that we can do with Numpy array. For example, we learn about the creation, about accessing a single element, accessing the last element, about slicing, about step slicing, accessing multiple elements, Boolean indexing, modifying elements, and negative slicing or reversing the array. So we're going to learn about all these 8 topics. First of all, this is my array. We learned how we can create it. We use np.array, and we are going to, inside the parentheses and square brackets, we're going to write down the elements of our array, and we assign the name of ARR to it. In order to access one specific element in this array, first of all, we need to learn about the indexing. So the first number in our array has the index 0. Then the next one has the index 1, 2, 3, 4, 5, 6, 7, 8, and 9. So this is basically how the indexing works here. So it starts from 0. So when we are looking for the element with index 0, it means that we are looking for number 10. The element with index 5, it's number 60, or vice versa. We can say, what is the index of element 90? The index is 8. So now that we learned about the indexing, we can access elements that are having different indices. So now I would like to access the element with index 3 of my array called ARR. So index 3, I write it in square brackets, and then the name of my array. So here it's the index 3 of array. We see it here. So if I change the name of array, I could say, for example, array 1, Then here I'm going to have array 1. So this way I'm going to print the index 3, the element with index 3 from array 1. So when I run the code, we see number 40. So index 3, we saw here the index 3 is for number 40. Okay, so we see that if we want to access number 40, we need to write down the index 3. So we are having an array called array 1. In order to access the element with index 3, we write down the name of the array, and in square brackets we're going to write down the index, which is 3 here, and we're assigning it to a variable called single element, and we are printing that single element, and it is going to print us number 40. And if we, for example, look for another index, for example, if I look for another index, which is index 8, we know that index 8 is the element 90. So when I run the code, we see number 90 in the output here. So it depends what we are looking for. If we know the index, we can access that element from the array 1 here, for example. Then we are having the last element to be accessed. So this is the name of array. So let me modify this again here. So another way of indexing is the following. So we can have indexing from left to right, starting from 0, but we can have from right to left as well. So we can call the last number to be -1, then -2, -3, -4, -5, -6, -7, -8, -9, finally -10. But we need to make it a bit closer to each other so they are going to be easier to be understand. So here is now the indexing. Let me modify the spaces. So you see here, now I'm having the indexing from right side. So indexing from left side is the following. We're going to start from 0, and we're going to continue until we reach the last element. Here we're having index 9. But indexing from right is different. So if we want to access a number that is the last element of our array, and we don't know how many numbers do we have here in our array, so we don't know that the last element index is 9 or 7, if it's 5, etc., because we don't know how many numbers do we have in our array. So this is why it's hard to start with the indexing from left hand side that starts from 0 if we don't know the number of elements. If we know the number of elements, for example, I know that we are having, for example, 10 elements here. I know that that element has the index 9. However, if we don't know the number of elements, or we simply want to access the last element quite fast, we can start from -1, because if we start the indexing from right hand side, starting from the last element, we always start from -1. Like here that we start always from 0 when we are counting from the left hand side. From the right hand side, it's -1 always. So the last element to be accessed, the index is -1, then 1 to the last is -2, -3, etc., until we reach the beginning of our array. So in order to access the last element of my array, I write down the name of my array. Then I write down the index -1, representing the last element in this array in square brackets. Okay, I write it in square brackets and assign it to a variable called last element. Then I print the last element. So when I run the code, we see that the last element is 100. So we learned that we can have the indexing from right hand side, but we should start from negative numbers. Then the next thing that we are going to learn here is slicing. So in order to learn about slicing, it's like we are extracting a sub array from the original array. So the original array is this array. I would like to have a sub array from this array. Now I would like to have the extraction of this array 1 from index 2 to index 6. Okay, and it is assigned to sub array. So when I run, we see that from index 2 to index 5 is being printed because the last element is exclusive. So index 2 until index 6. So index 2 is number 30. Index 6 is number 70, which is exclusive. Therefore, we are going from 2 to 5. So we are going from 30 to 60. And we see that 30 to 60 has been printed in the output. So we learned that if we want to have a sub-array, we write down the name of the array, then the starting point, colon, the ending point, which is exclusive. So it is going to return the elements from index 2 to index 5 and not 6 because 6 is exclusive, excluded, sorry. Then it is assigned to an array called subarray and we print the subarray here. So the next one is step slicing. The step slicing means that if we want to create a subarray but with our step. So when I run the code here, we see that we are having 10, 30, 50, 70, and 90. So we are having a step of 2 here, meaning that we are having the first element, not the second element, but the third element, not the fourth element, but the fifth element. Okay, so we are extracting every second element. In order to have such an extraction, we write down the name of the array, then colon 2 in the square brackets. It means that extract every second element. So it is extracts number 10, number 30, 50, 70, etc. until the end. And we can change this step. We can change it, for example, so every 3 elements, for example. So 10, 40, 70, as you see here, 10, 40, 70. So every 3 elements, it is going to extract that and assign it to a step array, and we are going to print the step array in the output. Then here we are having the array 1. In order to access, here we learned that we can access the elements using the indexing. So one element can be accessible through here and here, etc. But what if we want to access multiple elements at the same time? Now we can do it using this square bracket inside the main square brackets. So we are having the name of my array, array 1, and then we are having 1, 3, and 5. So it means that we are looking for elements with index 1, element with index 3, and element with index 5. And these are assigned to a variable called multiple elements, and it is holding our elements inside of it. So index 1, 3, and 5 are 20, 40, and 60. 20 index 1, 40 index 3, and 60 index 5. So we are accessing 3 elements that are having indices 1, 3, and 5. In the next example here, we are going to learn about the Boolean indexing. So when we are talking about the Boolean indexing, it means that we would like to have the extraction of elements based on a condition. So we are here willing to select elements from the array 1 that are larger than 50 and assign it to a new array called greater than 50 and then print it. So when we print these elements greater than 50, we see only the elements that are larger than number 50 is being printed here in the output. Okay, only the elements that are larger than 50, 60 until the end 100. So we see that here we can have the Boolean indexing extracting elements based on a condition, and the condition here is to have a selection of elements that are greater than 50. In the next example, we'll learn how we can modify one specific element in our array. For example, the array within the array, the element in this array with index 2 is 30. You see it here with index 2. In this array 1 is 30. We can have the modification of that element. So index 2, we write it down, the index 2 in a square bracket, then the name of my array. So I write down array 1 in a square bracket. I write down number 2, meaning that I would like to modify the element with index 2 in the array 1 and assign it a new value, for example, 999. And when I run the code and we print the whole array 1, here we see that the third element with index 2, instead of having number 30, it has 999 this time. So we learned how to modify it as well. Then we are having the next operation that we would like to have. So we can have the reversion of the array. So here we would like to reverse the array. How can we do that? We write down the name of the array. Then in square brackets, we are having colon minus 1. Colon minus 1 in a square bracket, helping us to reverse the order. So array 1, the name of my array, in a square bracket, we are going to have colon minus 1, and it is assigned to reversed array. When we run the code, we see that the array has been reversed, sorry. So we see that here the array starts from 10, 20, 30 until the end, 100. But when we see here in the output, we see 100, 90, 80, etc. until we reach number 10. So we reversed the array as we wanted. So here in this video, we not only reviewed how we can create a one-dimensional NumPy array. This is how we can create it. We reviewed the indexing from 0 from left-hand side. We reviewed the indexing from right-hand side, starting from -1, making it easier to access the last element. Then we learned how to access a single element using the indexing of that element. Accessing the last element also we discussed, we can have the -1 being there. Then we discussed about slicing, where we learned how to create a subarray from the original array. So for example, here we learned that we can extract a subarray from the original array that has the elements starting from the index 2 up until index 5, because the last index, which is here the 6, the number 6, the ending index, is exclusive. So it is excluded. Then we learned about how to do the step slicing, meaning that, for example, extracting every second element, every third element, etc. So we learned about that. We write down the name of the array, then colon, and then the step that we want to have. For example, when we are having the step 2, we're going to have number 10, then 30, and then 50. If we want to have a step 3, it's a third step. The step equals number 3. So we are going to have extracting every third element. It means that we can have number 10, and then 20 and 30 we don't have. Then we are going to have 40, then 50, 60 we don't have. So first, second we don't have. The third we are going to have because we are having the extraction every third element. Then we learned how we can have the access to multiple elements at the same time. We write down the name of the array. Then in square brackets, we're going to have 1, 3, and 5, meaning that we would like to access elements of the array 1 that has the index of 1, 3, and 5. Also, we learned about the Boolean indexing. For example, we would like to extract elements based on a certain condition. Here, the condition was the elements that are larger than number 50. We are having it here. Then we learned how to modify elements in our array. We write down the index in a square bracket and write down the name of our array, and it equals a new number. So for example, 999, meaning that the element with index 2 in array 1 is now equals 999. And then we learned how to reverse the order in an array. We write down the name of the array, colon, -1. Thank you for watching. Welcome back. In today's video, we're going to learn to perform different operations for our two-dimensional arrays. Here is the declaration of our two-dimensional array. We are having three rows here. So row 1, row 2, and row 3. We are having 4 columns, column 1, column 2, column 3, and column 4. So now if I want to make an indexing for this matrix, or let's say two-dimensional array, we can say the index of row is now row index is 0 because we said that we start from 0. Then we are having the row index 1 and then row index 2. So we are having the rows here. Let me make it nicer and more organized. So we are having the rows here. Okay, so we are having 3 rows. Row 1 with index 0, row 2 with index 1, and row 3 with index 2. And we are having 4 columns. So this is the column with index 0. This is the column with index 1. This is the column with index 2 and column with index 3. So here are the 4 columns with index 0, 1, 2, and 3. Here are the indexing of our two-dimensional array. Now we would like to access a single element in this array. In order to do that, we need to write down the name of the array, which is ARR. Then in square brackets, we should mention that the specific number that we are looking for is in which row and which column. So it says that the number that we are looking for is in row with index 1. So this is the row with index 1. And it is in the column with index 2. So column with index 2 is this one, and the row with index 1 is this one that we highlighted in blue. So index 1, row index 1, column index 2, meaning that we are looking for number 70. Okay, so now that we are looking for number 70, we should mention that it is in index 1, row index 1, and column index 2. And when we print it in the output, we see number 70. So the number that is in the row index 1 and the column index 2 from this array called ARR is assigned to a single element, and it is being printed in the output. But what if that I want to report number 110? In order to do that, we should have its row index, which is number 2. Okay, so index of row is 2, and this is the index of column, and column index is 2. And so when we run, we see that number 110 is shown in the output. If I'm looking for the address of number 50, so the row index is 1, so we are going to modify it to 1. Row index is 1, and column index is 0. So I'm going to put this 2 to be 0, and when I run, I expect to see 50 in the output, and you see that this is correct. So this was how we could access a single element in our two-dimensional array. Now we would like to learn how to access a row, an entire row we would like to access it. So here is how we can do it. So we write down the name of the array, which is ARR. In the square brackets, we are having 2 arguments that are separated by a comma. Before comma is about the row, after comma is about the column. So we would like to have the entire row, so we are going to simply write down the column, meaning that the entire column we would like to be, the entire row we would like to be printed. So we mean that the second row with index 1, the second row with index 1, we want it to be printed entirely. So we write down the name of the index of the row, which is 1 here, and then put a comma and colon, meaning that when we run the code, we see the entire row in this print in the output. The point that I mentioned, that before comma, everything is about the row, and after comma is everything about the column, is making sense for the accessing the element from one two-dimensional array, but not here. This one's when we wanted to retrieve the entire row, we're going to simply write down 1 if we are looking for the second row, which has the index 1, comma, and we put the column, meaning that we want the entire row to be printed. So when I run the code, you see that we are having the entire row, the second row with index 1. If I want to have the row with index 0, which is the first row, when I run the code now, we see 10, 20, 30, and 40. Okay. So instead of this column, if I instead of this column put a number, it will become exactly like accessing a single element with this row and this column. For example, if I write down the row index 0, the column index 2, it is going to print me number 30. So when I see the output, you see number 30 is there. But if I want to print the entire row with index 0, I simply write down comma and colon, and we see the entire row is being printed here in the output. So this is how we can have access to the entire row. And in order to have access to the entire column, we can simply write the name of our array, which is ARR, and we start by colon, comma, and then when we would like to print the third row, which has the index 2, we write down the index 2 here. So when I run the code, we see 30, 70, and 110. So 30, 70, and 110. So the third column is being printed with index 2. So we are putting the index 2 here. And because we want it to be entirely printed, we write down colon, comma, and then the index of that column. So if I want to print the entire column with index 1, like 10, 50, and 90, I put number 0 because 0 is the index of this column. When I run the code, we see 10, 50, and 90 here in the output. So this was how we could also retrieve the entire column. But what if we would like to do some slicing and extracting a sub matrix? In order to do that, we are having the name of our original array, which is ARR, and we are having in the square bracket, we are having a comma separating the extraction of the row and the extraction of the column. Meaning that now we would like to extract a submatrix for row 0 and 1. So number 2 is there, but it's not being included, the ending point. So 0 and 1 is included. So extract the row 0 and 1 and extract the column 1 and 2. Why not 3? Because 3 is exclusive, so it's excluded, so it's not going to be included. So exclude the rows 0 and 1. So this is row 0 and this is row 1, and column 1 and 2. So when I run the code, we see 20, 30, 60, 70 in the output. So we see index of the rows 0 and 1, so these two rows. And among them, we would like to have column 1 and 2, meaning 20, 30, 60, 70. 20, 30, 60, 70. So this is how we could create a submatrix in our code from the original matrix using this code. So this is what we called slicing. And we assign it to a submatrix, and submatrix is being printed later on. Then in the next line, we could have selection of specific rows or columns, for example. This is called fancy indexing. Here we are selecting the first row and the third row being assigned to the selected row. And when I run the code, we see that for the selected rows, we are having the first row and the last row, the third row being printed. So the first row is 10 to 40, the last row is 90 to 120. So we see that the first row and the third row, which is the last row, is being assigned to a new matrix. So in order to extract specific rows, we write down the name of our array. Then in the square bracket that are shown in yellow, we are having another square bracket here saying that from row, we want row with index 0 and we want row with index 2. and separated by a comma. They separated by a comma, and then we are having column, meaning that the entire row we are looking for. So this is going to extract row with index 0 and row with index 2 and assign it to the selected rows. And here we are printing the selected rows in the output. We could also have another, for example, rows. Instead of rows with index 0 and 2, I would like to have rows with index 1 and 2. Index 1 and 2 are 50 to 120. So when I run, now we see that we are having 150 from 50 to 120. So this is the selected rows. We can choose multiple rows to be extracted. Also, similarly, we could have the selection and extraction of multiple columns. Here, for example, we are trying to extract the second column and the fourth column. So second column, which is having index 1, the second column is index 1, and we are saying about the fourth column which has the index 3. So the second column with index 1 and the fourth column with index 3, we would like to extract only these two columns. We write down the name of the array. First we start with colon and comma, then in a square bracket we specify the index of the columns that we would like to extract, and all of them are assigned to selected columns, and we are printing selected columns. So we see 20, 60, 100, 20, 60, 100, 40, 80, 120, 40, 80, and 120. So the selected columns are extracted and assigned to a new matrix, and that new matrix is being printed in the output. Then we are going to have the Boolean indexing, talking about the extraction of elements based on a condition. So here we write down the name of the array, and the elements that are greater than 50, are going to be assigned to this greater than 50 matrix, and we are printing that out. So the elements that are larger than 50 are being assigned to a new matrix, and that matrix is being printed. So this is how we can have the extraction of our original array based on this condition. So each element that is larger or greater than 50. This is another point. Then we are having the modifying of element. For example, the element in row index 1 and column index 2. So row index 1 and column index 2, which is 70. Now I want to replace this 70 with 999. So when I run the code, we see that this number 70 is not there anymore. It's 999. So in order to do that, I write down the name of my array. Then I write the index of that number row that we are looking for, and then the index of that number column that we are looking for, and we are assigning it simply a new value. This new value is then modified in the original array. Then the next one is when we would like to access the last row and column of the original array. So in order to access the last row, again, we can use the -1 or -1 index. And in order to access the last column, we can have the -1 index again to access it. So in order to access the last row, we write down -1, comma, and colon. In order to access the last column, however, we first start with the colon, comma, and then -1. And both of them are assigned to last row and last column matrix respectively. And then we are printing them in the output. Here we see that we are having the last row. The last row is from 90 to 120. So we see from 90 to 120. And we are having the last column from 40, 80, and 120 are being printed in the output using the negative indexing. So in this video, we learned about accessing a single element in a two-dimensional array, or let's say a matrix. We learned how to access an entire row, how to access an entire column, and we learned about slicing, extracting a submatrix from different parts of the rows and columns. We learned about fancy indexing, where we are having the multiple rows being extracted or multiple columns being extracted. Then we had the Boolean indexing, helping us to extract elements based on a condition. We learned about the modification of a single element in two-dimensional array. And also we learned about accessing the last row and column in a two-dimensional array. Thank you for watching. Hello everyone, welcome to this video. In today's video, we would like to learn how to access elements and slicing in one-dimensional NumPy arrays. So here is my NumPy array. This is how I'm creating the NumPy array. First of all, I am importing the NumPy library as np, so I use np.array. Then these are the elements in the square bracket, the elements that I am initializing for my NumPy array, and it is called array one-dimensional. And these are the elements. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So there are 10 elements here. And before we learned about the indexing here for arrays, for example, when we want to have the indexing, we're going to start from 0. Then we're having 1, 2, 3, 4, 5, 6, 7, 8, and 9. So when looking at this, we realize that if we are indexing from the left-hand side, we are going to start from 0. So the first element has the index 0, and the last element has the index 9. So if I'm talking about an element with index 5, it means that I'm talking about number 60. So this is what we need to keep in mind. Also, we learned that if we want to label from right-hand side, we are going to have -1. For the last element, we have -2. Then we have -3, etc. until we get to the first element here. Okay. So indexing from left-hand side starts from 0. Indexing from right-hand side starts from -1. Now, we're going to learn how to access elements in one-dimensional NumPy arrays. In order to access, for example, the element with index 3, which is number 40, we write down the name of the array, which is array one-dimensional. And then in square brackets, we are going to write down the index of that element. So if I'm looking for number 40, I need to write down its index, which is number 3. So name of the array, and in square brackets, the index of that element. And this is assigned to a variable called a single element one-dimensional. So when I run the code, here I'm having the print of the single element. So I say single element at index 3. And this is the print of the original array. When I print this is the original array, we see it in the output. And the single element at index 3 is 40. We see it in the output simply here. So when I want to access 40, I need to access through its index, which is 3. If I change it to another index, for example, here, if I say I would like to access element at index 5, for example, I revise this number here in the print as well. But here I'm telling the compiler I want the element with index 5 from the array one-dimensional array. And index 5, we know that it's number 60. So when I run the code, we see 60 being printed out in the output. So this is how we can access element while we are using the indexing from left-hand side. But it's easier, let's say, to access elements from right-hand side at some point. Why? Because at some point we may need to have the access for the last element. And if we don't know the size of the array, we don't know if it's number 9, number 10, or we don't know how many elements are there. So we don't know how many indexing we need to know about. So this is why when we want to access the last few elements, it's better to use negative indexing. meaning that if you want to access the last element, although you can do it through index 9, but if you don't know about the size of the array, or you need to count it to see, okay, the last element, like the way that I did here. So 0, 1, 2, 3 until you reach the last element and see, okay, now it's number 10. Number 9 is the index of the last element. But in order to make it easier, what we can do is to start from -1. When we start from -1 or -1, it means that we are talking about the last element. If I write down -2, it means that I'm talking about the second to last element, third to last element, -3, etc. So in order to access the last element, we simply write down the name of the array, and in square brackets, we are going to write down -1. We assign it to a variable called last element one dimensional, and we are printing it here, last element one dimensional here. So we see that the last element, it says 100. So because we used -1 or -1. If I write down -2, we are going to have the second to last numbers, which will be 90. So I have 90 here. If I write down -3 and I run the code, we are going to get 80. -3 is 80. And we know that if we use the left-hand side indexing from the left side, let's say, if we want to access number 80, we can write down index 7. So when I run the code now, we see that indexing from left side it's 80, and from the right side it is 80 as well. Why? Because we either can use the indexing from left side, starting from the left side, or from the right side here. So 7 and -3, they are both talking about specific element that we are having in our array. So this is how we can access different elements of our array. Then let's talk about the slicing. So slicing means that we want to get some part of the array, but not the full array, or maybe we would like to reverse the array. So we would like to work with the array, the original array, and have a sub array, let's say, or maybe we would like to reverse it, we would like to skip some of the elements, etc. So this is what we call slicing. So in this video now, we would like to learn about slicing about one-dimensional arrays. In order to do the extraction of the elements of an array, or let's say doing the slicing, we're going to write down the name of the array, which is array underscore 1D. Then in square brackets, we need to mention the indices that we would like to have in the extraction. So this is the starting point, number 2, before colon, which is number 2, the starting point. After the colon, it's the ending point, but it's exclusive. So number 7, when it's there, it is not included, and number 6 is included. So it is going to start from 2 and ends at 6 included. Okay, so it means that I would like to create a new array starting from index 2, ending at index 6, starting at index 2, ending at index 6. So I would like to create an array from 30, 40, 50, 60, and 70, and assign it to slice 1D. And when I print slice 1D, you see exactly 30, 40, 50, 60, 70 is there. 30, 40, 50, 60, 70 is there. So now in order to do the slicing, we simply write down the name of the array, then the starting point and ending point. And we need to keep that in mind that ending point is exclusive. This is one thing. Another thing is that what if we would like to have every second element? So it means that I want 10, then I don't want 20. I want 30, I want 50, I want 70, I want 90, etc. until the end. In order to have this, we write down the name of the array again. Then we write down colon, colon, and number 2 because we would like to have every second element. And this is what called a step slicing. So we are assigning the new array, which has the every second element of the original array. We are calling it a step slice one dimensional, and we are printing it here. So we see 10, 30, 50, 70, and 90. If we would like to have every third element, we could simply write down 3 here. So we are going to have 10, 40, 70, 100. 10, 40, 70, and 100. So it depends what we are looking for, but this is how we can do step slicing. And finally, if we would like to have the reverse of the array, we can write down the name of the array. Then in square brackets, we are going to have colon colon minus 1. When we are having colon colon minus 1, simply we are reversing the array, meaning that we are telling the compiler, okay, start the array from the right side, meaning that from 100. And this new array that we are creating, we are reversing from the original array, is assigned to reversed one-dimensional array. This is the name that we choose. And when we are printing it here, we see that we are having a reversed array being shown here in the output. So in this video, we learned how to access elements and different type of slicing in one-dimensional NumPy arrays. Thank you for watching. Hello everyone, welcome back to this video. In today's video, we're going to talk about creation of one-dimensional array, Boolean indexing, fancy indexing, and iterating through a one-dimensional array. So here is my one-dimensional array. It has 10 elements. You see it here. Now I would like to have the Boolean indexing, meaning that we are going to extract elements that are, for example, greater than 50. In order to extract these elements, we write down the name of the array. Then in square brackets, we mention that each element in this array that is larger than 50 is assigned to a new array called greater than 50, and here we are printing it out in the output. So we see that the elements that are greater than 50 are the following: 60 until 100. So here, using a Boolean indexing, we learned how to extract elements that are greater than 50. We could also have, for example, greater than 60, for example. So if I run, we see as of 70 is being printed here. So greater than 60 are the 170, 80, 90, and 100. We could have, for example, lower than 60, for example. And here we're going to have these numbers in the output in the new array: 10, 20, 30, 40, and 50. So depending on what we are looking for, we can modify this. Also, with respect to the fancy indexing, we can have selecting elements at specific positions. For example, now I would like to, this is my original array. I write down the original array name. I would like to select elements at indices 1, 3, 5, and 7. So let me start indexing this one. So this is 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. So I would like to select elements at indices 1, 3, 5, and 7. So 1 is number 20, 3 is 40, 60, and 80. So I would like to have them. So I write down the name of the original array, and in square brackets, we write down 1, 3, 5, 7, separated by commas. Then it is assigned to a new array called fancy indices. So when I print the fancy indices, we see 20, 40, 60, 80, as we expected, is printed there in the output. So this is also very nice to have the possibility to access multiple elements in one line, instead of having multiple lines. In each line we are having the access to only one element. Okay, so this is how we can access multiple elements. We call it fancy indexing. And also, in order to iterate through the array, we can show this message first of all, and then we have the iterating variable called value. And we are saying that for each value in our array, one-dimensional array, print the value. And here we see that we are having everything of the original array being printed. And this end means that print everything in one line and also provide one space between for each iteration. So in this video, we learned how we can create a one-dimensional array. We learned about Boolean indexing, for conditions that we would like to check. For fancy indexing, we learned how to have access to multiple elements, and also we learned how to iterate through the array. Thank you for watching.